All right, so this is the second matrix video. This is basically going to cover matrix multiplication, okay? Excuse me. So basically, when multiplying the two matrices together, the absolute first step that you need to do is, first off, determine if you can multiply these matrices, because not every matrix, kind of like how addition, in which there's only a certain amount of matrices that you can multiply together. It's kind of like that you can add or subtract together. There's only certain types of matrices that you can multiply together, okay? Now, basically the way you determine this is the number of columns in the first matrix have to match the number of rows in that second matrix, okay? And again, remember, going back to the last video, rows are first, columns are the second number, okay? So you have rows first, columns second. Now if we take a look at this, example 8 right here, we take a notice that this first matrix, it's a 2 by 3 matrix, and then the second matrix is a 3 by 4 matrix. So if I basically look, I got the number of columns in the first matrix. If you need to label it 1, this label 2. Label this is 3. Number of rows in the second matrix is 3. You tell that these are the same number and that yes, you can multiply those out. Basically, this is kind of the trick right here, okay? You basically list the first dimensions of the first matrix and the dimensions of the second matrix. If the inside numbers match, then you can multiply them out, okay? Go over to example 9. We have the first matrix here and then the second matrix here. It's a 3 by 2 matrix multiplying by a 3 by 2 matrix. We cannot multiply these out because, as we see, we have the number of columns in this first matrix multiplied by the number of rows in this first matrix. 2 and 3, and the last time and if you need just a clarification, 2 is not equal to 3, so we cannot multiply those out, and that's where you leave it. You'll have some examples like that where you will not be able to multiply them out, and if that happens, you basically just say no or undefined or just can't multiply, okay? Now example 10 here, kind of hard to see down here, but you basically have 1 and then not 1 by 9 matrix for our first matrix. Then our second matrix is the 9, okay? And again, you always write your first matrix, well, to the left, and your second matrix to the right, okay? So you write this one left to the right. And again, you notice 9, our inside numbers here match, so that means that yes, we can multiply those out, okay? And then last but not least, you got example 11, you got first matrix, and then the second matrix here. You have 4 amounts of columns in the first matrix and 4 number of rows in the second matrix. These numbers here match, so therefore, yes, we can indeed multiply those matrices out, okay? So again, first step here, you need to determine whether or not you can even multiply these, all right? If you get one like example 9 where you just can't, you just say can't multiply because number of columns in the first one don't match the number of rows in the second one, and you move on, okay? That's all you have to do for that, all right? Now, this is kind of the little cheat sheet thing that a lot of people were asking about, and how to multiply matrices out. And again, the one thing that I'll add to this is whenever you are multiplying matrices out, label your rows in the first matrix and then label your columns in the second matrix, all right? And that's really the only thing, and actually I'm going to kind of color code these. I'm going to pause it real quick. Okay, so I kind of color coded these, but basically any time that you are multiplying matrices, the thing that I always recommend, label the rows in your first matrix, which again, this is this one, and then label the number of columns in the second one. Again, rows, remember, the numbers that are going from left to right, and then the columns, the numbers that are going up and down, all right? Label your rows in the first one, label your columns in the second one, all right? And again, if you guys want to maybe take a picture of this or screenshot this or something like that, pause the video real quick and you can do that. Otherwise, we are moving on to a couple examples here, okay? So we have example AB. I'm gonna go ahead and write out these matrices here. So you got 3, -6, -5, and 8, and then 12 and 20. So we got to basically determine whether or not we can multiply these out. Let's just go ahead and determine the dimensions of all these. A, remember, 2 rows that are going left to right, 3 and the 6, the 3 and the -6, the -5 and the 8. 2 columns going up and down, 3 and the -5, and then the 6, and then the 8. So this is a 2 by 2 matrix. B, we have 1 column, but we have 2 items in that column. So we know we have 1 column, and we have 2 items, which basically count as our rows, so it would be 2 by 1 matrix. And then C, last one here, we have 3 sets of numbers going from left to right, so 10 to the -7, 3, 5, -3, 5, excuse me, then 8 and -6, and then 3, and then 2 sets of numbers going up and down, which are our columns, the 10, the -3, the 8, and then the -7, the -5, and the -6. So this is a 3 by 2 matrix. So let's take a look at this, starting with AB. A is a 2 by 2 matrix. And then B is a 2 by 1 matrix. You see that the number of columns in the first one match the number of rows in the second one. So we can indeed multiply these, and we're going to move on to doing so. Now, one thing that is going to help you with this is knowing how to find the dimensions of the last matrix. Now, there's a little bit of a cheat here for how you can do that. Basically, you have these inside numbers here, the 2 and the 2. What we're going to do is essentially cancel them out. We're not really canceling, anything in our problem with our matrices or canceling any of the rows or columns out. We're basically going to kind of, in spirit, cancel out the 2 middle numbers, and then we're left with the 2 outside numbers, the 2 and then the 1. All right, so we know that we're going to have a 2 by 1 matrix, which is essentially a matrix with something here and something there, okay? Something on the top, something on the bottom. And so let's go ahead and multiply it out. Now, it's not as simple as just, hey, multiply this 3 by this 12, or multiply this -6 by this 12, or the 20, or whatever. What we do is we're going to multiply the 3 to the 12, and then I'm going to go green here, and then the -6 to the 20. So I'm going to go ahead and write those out. We're going to have 3 times 12, and then -6 times 20. And then when we multiply all those numbers out, we actually add those numbers, and that is going to be the new number in our new matrix. So again, if we just add those numbers up, we multiply 3 and 12 gets us 36. The -6 and the 20 gets us a -120. If you do 36 minus 120, can't do that off the top of my head here real quick. Let's just get a calculator out. 3 minus 120, that just gets us -84. And that'll go on the top of our matrix there. That goes on the top there. Again, one way you can kind of determine where it goes is basically I'm multiplying this first row by the first column. So it's going to be in the top row in, well, basically what's our only column, okay? And so we essentially do the same process, but since there's no more columns, basically we start with the first row, label your rows, label your columns. You start with this first row here, and you multiply it by every single column in your second matrix. But since we don't have another column in this next matrix, we go on to the bottom here, okay? So you start off with, in the same kind of process, the -5 in the 12. So I'm going to do -5 times 12. And then I'm going to go, then we go the 8 times the 20. And again, -5 times, that gets you, oh, excuse me. Excuse me, sorry. Sorry about that. You get -60. and then plus 8 times 20 is 160. Add negative 160. Remember, we're adding these numbers together. Negative 60 plus 160 gets you 100, okay? And that is your new matrix, okay? That is your new matrix, okay? Now, I'm going to pause the video, set up the next bunch of matrices, and give me 1 second to do that. Okay, so, and one thing I just remembered here, it kind of got rid of our dimensions up here when I kind of erased it. So basically, we erased everything, set up this new matrix right here, CA and C times A. We look here, C is a 3 by 2 matrix, and then A is a 2 by 2 matrix. So we know that these inside numbers here match our number of columns in this first one, match the number of rows in the second one here. So we can go about our business here. I'm just going to go and erase that. Now, again, make sure in this first one, and only the first one, you label your rows. And then in the second one, you label your columns, all right? So this one go blue. So label your columns, label your rows. Now, let's go ahead and multiply out these columns here. And again, we are adding every single one of these terms that we multiply. So we go 10 and the 3. So we go 10 times 3 plus negative 7 times negative 5, okay? Which gets me 30 and then a negative 35, actually a positive 35, which gets me 65. My two outside numbers are a 3 by 2, so I know that I'm going to have a 3 by 2. I'm going to write this over here, actually. So I'm going to have 65, and that's going to be the top left number in my matrix, all right? Again, if you look at what we're multiplying, it's this top row and in the first column. So you know in your new matrix, you're going to multiply your new number is going to be in the top row in the first column, okay? Now, unlike the first example that we did, we actually have a second row, we have a second column, to multiply this first row by. Again, we basically go row times column, row times the second column, and then once we run out of columns, we move on to the next row and then multiply them all by the columns. And so essentially, let's do this. We do 10 times the negative 6, and we're still adding negative 7 times 8. You get a negative 60 plus a negative 56. You get yourself a negative 116. Remember, we're adding in the first matrix. We did the first row, but this time we did the second column, so we know that it is going to go right here, negative 116. All right. If you need to pause it to get this work, do that. I'm going to go ahead and erase it just so I can work out some of the other stuff as well. And again, that was just for the first row up top there. All right. Then I've run out of columns to multiply this top row by. Now I'm going to go down to the second row and start again at the first column. All right. So you start with the negative 3, multiply it by the 3. And then go 5 times the negative 5. Still adding those together. You get negative 9, negative 25. Add those together, you get negative 34. It's the second row times the first column. So it goes in negative 34 here, okay? Then we move on to the next row. Move on to the next column, Do negative 3, multiply by this 6 here, negative 6, add the 5 times the 8. You get yourself 18 plus 40, you'll get yourself 58 here, all right? I'm going to pause the recording real quick to work out these. All right, so basically we finished up the multiplying this last row here by both of these columns. Again, I kind of labeled them 1 and 2 up here. Again, as you basically go from left to right in these rows, you go up and down in your columns. All right, that, y'all, is matrix multiplication.